Hello and welcome to another session in mathematics. In this session we'll be looking at logarithm. But before that, let us take a review of our previous lesson. Welcome back. Because of today's lesson, we'll revise everything we've done on logarithm in the past years, and then we'll look at the laws of logarithm. So we'll be treating the revision of logarithm, including all the laws of logarithm. So let us start. When we talk about the term logarithm, I will say that the logarithm of the number y to a base a, written as log y base a, is the power to which a must be raised to get y. Okay, that is to say, if we have log y base a to be equal to x, it simply means that a raised to power x is equal to y. Remember, the a here is the base. Okay, now if we have log y base a to be equal to x, it means that a must be raised to power x for us to get what? The value of what? Y. Okay, so if we have let's say log 4 base 2, log 4 base 2 is simply 2. Do you know why? Because 2 here raised to power 2 is what will give us 4. Let us say, let log 4 base 2 be x. Remember, when we have something like this, we say 2 raised to power x is equal to what? 4. So we have 2 raised to power x is equal to 4, and this is equal to 2 raised to power 2. So 2 raised to power x is equal to 2 raised to power 2. Then x is equal to what? 2, because this will eliminate these 2. So x is equal to what? 2. That was why I told us that the answer here is what? Is 2. Now when we have log let's say 32 base 4, log 32 base 4, how do we ascertain the power of 4 that will give us 32? Let's call it x. Therefore it means that 4 raised to power x is equal to what? 32. And 32 is something as 2 raised to power 5. Y4 is equal to 2 raised to power what? 2. Is that correct? So we say that 2 raised to power 2x is equal to 2 raised to power 5. This will cancel this. 2x is equal to 5. X is equal to 5 over 2. Do we understand? So that means that log 32 is something as what? 4 raised to power 5 over 2. Do we understand now? So if we have let's say log 16 base 0.25, what do we do? Let this be equal to x. If this is equal to x, it means that 0.25 raised to power x is equal to what? 16. But remember that 0.25 is the same thing as 25 divided by 100. Is that correct? So, and that will give us 25 into itself is 1. 25 into 100 is what? Is 4. That will give us what? 1 over 4. So, and 1 over 4 is something as 1 over 2 raised to power what? 2. Is that correct? And then by law of negative index, when we have 1 over x, is something as x raised to power minus 1. And when we have 1 over x squared, is something as x raised to power minus 2. When we have x raised to power minus 3, is something as 1 over x raised to power 3. So with this idea now, we now have this to be 2 raised to power minus 2. Okay, so 2 raised to power minus 2x, because of this x here, is then equal to 2 raised to power 4. Since 16 is 2 raised to power 4, therefore this 2 will eliminate this 2. Minus 2x is equal to 4. X is equal to 4 divided by minus 2, which will give us minus what? 2. Do we understand? So these are the basics of logarithm. So let's quickly go over to the laws of logarithm. The laws of logarithm. We have the first law The first law is the addition law, which states that log mn base a is the same thing as log m base a plus log n base a. Okay, this is the addition law. That is to say, if we have let's say log 3 plus log 4 is just the same thing as log 3 times 4, which is what? Equal to log 12. Okay, you can rewrite this to this form, and you can rewrite this too to this form. Okay, so when we have log m base a plus log n base a, it's equal to what? Log mn base a. Mn here means what? Multiplication. So when you're dealing with multiplication in this logarithm, you apply what? Addition. And when you're dealing with division, then you apply what? Subtraction. So assuming we have log 2 base 10 plus log 50 base 10, all you have to do here is to write down the log and the base, since they are of the same base. Log they are all what? In base 10. So you write down log and then the base, you open a bracket, you multiply these numbers here, so you have 2 times 50. Okay, and that will give us what? Log 100 base what? Base 10. But remember, log 100 base 10 is equal to log 10 raised to power 2 base 10. Is that correct? And then that will give us 2 log 10 base 10, and that is equal to what? 2. Do we understand? So let's go back to the second law. We have the subtraction law, which states that we will have log m base a minus log n base a, that it's simply log m over n base a. Okay, I told us that when we talk about subtraction, then we deal with what? Division, and vice versa. So if we have log 15 minus log 3, all we need to do here is to write down the log and then divide these numbers. We have 15 all over 3, and that will give us what? Log 5. As simple as that. Assuming we have log 100 base 5 minus log 4 base 5, what do we need to do? We write down our log and the base, which is 5, and then we'll have 100 divided by what? 4. So at this point, what do we have? We have log 100 divided by 4 will give us 25, and remember the base is 5. But 25 is something as what? 5 raised to power 2, 5 squared. That means that this will give us log 5 squared base 5. Okay, and log 5 squared base 5 will give us 2, that is this power here, bring down this power here, then log 5 what? Base 5. And then when we have something like this, this is equal to 1. Do we understand? When we have log 5 base 5, it's equal to 1. When we have log 10 base 10 is equal to 1. So because this is 1, we will then have 2 times 1, which is what? 2, as our answer. That was how we got this one here to be 2. I know you were confused how I got that, so that's why I have to call your attention to that. Okay, so let's go back to the third law. The third law of logarithm. We have the power law. The power law, if we have log m raised to power p base a, log m raised to power p base a is equal to p log m base what? A. That's exactly what we applied on the examples we took in the previous law. Assuming we have log 32 squared base 2. this is simply bring down these 2 log 32 base 2. Do we understand? And then remember that in base 2, 32 is equal to 2 raised to power 5. Is that correct? So leading us to having 2 log 2 raised to power 5 base 2. Is that correct? So this and this will then give us what? 1. So we have 5 coming down here. Like I told us that this is equal to this. So this 5 will move down to come and meet these 2. Therefore we have 2 times 5. Then log 2 base 2. 2 times 5 is what? 10. And I told us that when we have something like this, it's equal to 1. So we have 10 times 1, which is what? 10. And that's the answer. Assuming we have another problem, let's say log 5 raised to power 3 is something as 3 log 5. As simple as that. Law 4, the fourth law states that when we have log a base a that is equal to 1, when we have log a in base a, it's equal to 1, logarithm to its own base. Assuming we have log 10 base 10, I told us that earlier that is equal to 1. When we have log 20 base 20, it's just 1. When we have log 3 base 3, it's 1. Just bear it in mind that logarithm to its own base is equal to 1. Okay, so let's go over to the fifth law. The fifth law, we'll call it logarithm of 1. Logarithm of 1. Logarithm of 1. Okay, when we have log 1 base a, it's equal to 0. Okay, because logarithm deals with what? Tens. Logarithm deals with what? 10. So the logarithm of 1 to any base is equal to 0. Logarithm of 1. So if we have log 1 base 5 is equal to 0. If we have log 1 base 10 is equal to 0. Let me prove that. Assuming we are working with log 1 base 5, log 1 and base 5, this is equal to saying let log 1 base 5 be x. Is that correct? Let log 1 base 5 be x. It means that 1 is equal to 5 raised to power what? X. Is that correct? And then when we have this, remember that 1 is something as 5 raised to power 0, and we have 5 raised to power x. Is that correct? Because anything raised to power 0 is equal to 1. So that means that x is what? Is 0, because this will cancel this. Assuming we are working with this of 10, we have log 1 base 10 to be x. It invariably means that 10 raised to power x is equal to what? 1. Is that correct? So we then have that 10 raised to power x is equal to 10 raised to power 0, since anything raised to power 0 is 1. Okay, therefore x is equal to 0, because this 10 will eliminate this 10. Okay, so we say that the logarithm of 1 to any base is equal to 0. Okay, law 6. Let's look at the sixth law. The sixth law, we call it reciprocal law. Reciprocal. Reciprocal law. We have log m base a to be equal to 1 over log a base m. If we have log a base m, if we have log m base a is something as 1 over log a base m. Let me give us an example. Assuming we have log 9 base 3. Log 9 base 3 is something as 1 over log 3 base 9. Okay, how do we explain that better? If we have log 9 base 3 is something as log 3 squared base 3, right? And then that means that our answer is what? Is 2. Is that correct? But if we're dealing with 1 over log 3 base 9, we have our results to be 1 over log 9 1 over 2 then base 9. You know, when we have 9 1 over 2, fractional law of index, it simply means square root of 9. Is that correct? Which will give us what? 3. Okay, so when we have x raised to power 1 over 2 is something as square root of x. Okay, so considering that, now we see now that they are now of the same base. Is that correct? 9 and 9. So this will comfortably cancel each other. We then have 1 over 2, which is equal to 1 times 2 over 1, and that will give us what? The same 2 we got here. Do we understand now? So let us take the last law, the 7th law, which we'll call change of base. Change of base. If we have log m base a, it's equal to log m base y all over log a base y. Okay, so just bear this in mind. When the base of a logarithm is changed, the initial base is used as a separate logarithm to divide the initial logarithm or to the new base. Okay, so just bear this in mind. So let us take some examples of logarithms with that table. Assuming we have 2 log 3 plus log 6, and we are asked to evaluate this. What do? We have this to be equal to log 3 raised to power 2 times log 6, 9 times 6, and that will give us what? Log 9 times 6 is what? 54, and that's just the answer. Assuming we are given let's say 2 minus 2 log 5. What do? We have this to be equal to log 100 all over log 5 squared. Is that correct? Remember, I told us when we are dealing with minus, it means what? We are dealing with what? Division. Minus and division is the same. Why, when you're talking of multiplication, then it is what? Addition, and vice versa. So here we are dealing with minus, and it simply means all we are dealing with is what? Is division. Is that clear? Fine. So looking at this now, what do we have then? We then have this to be equal to log 100 all over log 25, and 100 divided by 25 will give us what? 4. So we have log 4 as our answer. Okay, if we are given log 4 base 10 plus log 25 base 10, all we need to do here is to bring one of the log and the base, since it is in base 10. Then we have 4 times what? 25, and that will give us what? Log 100 base 10. But remember, log 100 base 10 is something as log 10 squared base 10. Is that correct? So we have 2 log 10 base 10, and then this will cancel this since it is 1, and then 2 times 1 will give us what? 2. So giving us our answer to be what? 2. Do we understand now? So we'll stop here today. Thank you for being part of today's class. In our next class, we'll go over to the use of tables in solving logarithm. Welcome back. Do well to use the lesson note on the platform for better information on what we've done so far, and feel free to drop your questions on the comment section. Till we meet again in our next class, stay safe. Bye.